Yeah, going for the topics. Today's topics are first one fuel injection system for CI engines and electronic diesel control and the components of the diesel supply system and the fuel injection and the introduction of the ignition system and CRDI, that is a common rail fuel injection system and a turbocharger. Okay, so these are the today's topics. I don't know how much we can going to cover today, but I think most of these topics we will cover today. Okay, right. So first of all, we are going to study about the fuel injection system for the CI engines. In the previous classes, we were discussed about this SI engine systems. Okay, the fuel injection system for the SI engines. You know, the SI engine is a spark ignition engine. And current in this today's class, we are going to discuss about the CI engines. So what is meant by the CI engine? That is a compression ignition engine actually. So the major difference between the CI engine and the SI engine is that it is in CI engine there is a compression, the ratio of the compression is higher, and also there is a no spark plug is occurring there. Okay, so that is the main reason here the difference between the SI engine and CI engine. So the compression ratio of the CI engine is more than the SI engine. Okay, and also the compression and also this in the inside the fuel is different actually. We are going to use the fuel is different. So here we are going to study about the fuel injection pump in the beginning. So what is exactly this fuel injection pump? So it is one of the major important component in the fuel injection system. So the fuel injection system that fuel injection that the pump is sucks the fuel from the tank actually, and it gives a pressurized approximately 600 to 1000 bars. See, this pressure is very far different than the SI engine actually. Okay, so in the FIP, that means the fuel injection pump, it has a separate pumping chamber for the cylinder, each cylinder. Okay, so it has a one pumping chamber that pump and distribute all over the cylinders in the sequence as per the firing order of the injectors. Okay, so here the firing order, it means that there is a no firing fuel spark plug is present there, but the firing order, it means that in each cylinder there will be a fire is formed actually. Okay, so but it is not because of this our injector actually or the spark plug. Okay, so what happens is we collect the fuel by using the fuel injection pump, and these we have given separately each cylinder. Okay, and this pump is uses a high pressure pump. So this pump gives a high pressure inside the cylinder also. Okay, so that is it inject the high pressure fuel into each cylinder, and meanwhile you have to understand there is a fuel filter should be present in here, because this in this case there is no contaminant should be present inside the cylinder. So that is why a fuel filter is must in between there actually. Okay, so it remove the dirt and the sediments. Okay, dirt and the sediments while it should not reach in the inside the cylinder. So that is why we will remove. There is a lot of dirt and sediments are will be present in the fuel, and we will use a fuel filter for removing all these things. Okay, right. Now what we are going to do is we are injecting this fuel into the inside the cylinder actually. Okay, so in the inside cylinder, that means in the compression ignition engine, the fuel is injected into the combustion chamber, and it mixed with the air, and then suddenly it ignites actually. See, here we are taking the air is actually more than the fuel actually. Okay, so a huge amount of air. So that is why I told you the compression ratio is actually different. Okay, so the compression ratio is actually very far difference than the SI engine. So suppose you imagine that SI engine have 1:4 or something, then the compression ignition is 1:20. That is a 20 amount of the volume of this air which is mixed with the one volume of this fuel. So in the case of SI engine is very lesser. So here the amount of the air is different actually. Okay, and the fuel is very slow or very lower amount of the fuel is required. So that is why the mileage, you can see that the diesel engine cars having a lot of mileage actually. So there is a inside the diesel engine cars is having a more mileage. You can see that in the outside in the diesel engine cars like Maruti cars, etc. They're having the more mileage like 28, 30 kilometer per liter. But in the case of other SI engine cars like Swift cars, all these cars having a lesser mileage than the combustion ignition engine or these diesel cars. Okay. Now we are going to see here there are two types of the methods we are using. That is a direct injection and indirect injection. Okay, direct injection and indirect injection. So here inside there is we are supplying the fuel in the two type of methods, which is the direct injection method and other is the indirect injection method. Okay, now we go for that actually. So before that, another component we have to study about the some major components inside this diesel CI engine. Okay, so first one is the electronic diesel control. So what is exactly this electronic diesel control? So this is a control system that control how much amount of the fuel should be given for the combustion chamber. Okay, or this is situated in the heavy trucks and cars actually. Okay, so this is a modern equipment that decide how much amount of the diesel should be present or give from the tank to our cylinder actually. Okay, so എത്രയാണ് ഈ ഒരു cylinders should be cylinders like എത്ര amount of diesel should be provided എന്ന് decide ചെയ്യുന്നത് this electronic diesel control ആണ്. Okay, so there is a mechanical be a variety of the engine's loads. Okay, so you can see that the engine loads are different actually. Okay, see in the heavy trucks the load will be more, but in the cases of cars the load will be lesser. But so there is a difference in the using the different types of engines, and these engines having the amount of the volume of the fuel is distribution for each cylinder is also different. Okay, so that depends upon the efficiency and the emission control and the power and the fuel consumption. So all these things are very important, and also all these things are related with the load actually. Okay, so here we are providing the electronic diesel control that controls all over the how much fuel we have to give in each cylinders depending upon the load and the power required and also the emission and the efficiency also. Okay, so these demands are now primarily fulfilled by this electronic control system, and that provide a greater ability to precise the measuring and data processing and all these operating environment. Okay, so this is fully controlled by the electronic, and also there is some mechanical connection parts and also these mechanical items which is controlling by using the electronic control. Okay, we will go for more about this. Okay, so there is a electronic control having some further small divisions or some small components are inside this electronic controlled diesel supply. So what are they actually? The first one is the electronic sensors. A lot of sensors are there available for this to control this one actually. See, these electronic control the electronic sensors which registering the operating condition and changes. See, you have a lot of sensors are available. These sensors detecting what are the parameters, and these parameters they take into and they made an array of physical input by using the converting the electronic signal output. These sensors these sensors detect what are the need is required for the particular application, and these sensors give an electrical signal output, that output which passes through a solenoid. Okay, see there is a solenoid is connected with this one mechanism, and this solenoid will collect the all the signal electronic signals and these signals into a mechanical movement. So that actuator or the solenoid that convert the total control of the unit of the electrical output signal into a mechanical control movement. See, so the first thing is the electronic sensors. These sensors collecting all the data, and these data as an electrical signal output, and that output we are collecting this system, and what happens, we will give a small reactions. See, we will get the reactions and we will give the okay, like here, ECM, that is an electronic control module, the second part. So inside there, an electronic control module is there. That electronic control unit or these components of the microprocessors that process that information, and this information is programmed software. It's in a programmed software inside, and also this programmed software is collecting all the data and process, and then it makes a requirement of the electrical signal. So that create some information, and that create the emotion inside the physical or the actuator or the solenoid. See, so it's just like this, that there is a lot of sensors inside the car, and these information, that information getting as an electrical signals, okay, as an output, and these signals are coming to this our electronic control diesel supply or this ECM module, and this ECM module, what the ECM module doing is, ECM module is collecting all these data and making a process of information, and also this there is a inside, there is a software, that software collect that data and it process and then give a suitable information to our actuator or the solenoid, and that solenoid create a mechanical control, okay, or a mechanical output, okay, to the respective environment, okay, right. So yeah, here these are the sensors we are using for this. See, you can see that what are the sensors are available in here. You can see there is a injection pump speed sensor. So that monitor the pump rotational speed, and the second one is the fuel tank rack position sensor. So it monitors the pump fuel rack position. So it means that it understands how much fuels are there inside. And the next one is the air pressure sensor. So it measures the pressure side of the turbocharger, and the fuel pressure sensor, air cleaner sensor, and the engine position sensor, and the temperature sensors, and the intake temperature and output temperature, and coolant temperature, fuel temperature, and the exhaust gas temperature. Okay, so and also the ambient temperature. So these are the temperature sensors, and some various other sensors are the vehicle speed sensor that monitor the vehicle speed, and also there is some brake pedal sensor which actuate, which create or operate the cruise control or the exhaust brake or the idle control. All these are the connected with the sensor, and these sensors are collecting the information and giving the electronic control modules. Okay, so that control module is a programmed module, and it is also decided what is needed, okay, what is the next step or what is needed to the next step, okay, and it gives that information to whom, it gives the information to the governors or the transmitters and all these actuating mechanisms, okay, right. Next one is the electronic control unit. See, I will give you an example. That is when a particular damage happening in our car. Actually, suppose you imagine that when we are going to a travel, or when we are going to some trip, suddenly the car stops. We don't know what happens in there actually, but we will see in our monitor. You can see that there is the petrol is empty. Okay, how you understand about the petrol is empty actually? So there is a petrol sensor, that is there is a sensor that senses and that gives to our module, and that module is showing as a output like a screen. Inside the screen we can see that the petrol is empty. See, this is a very small example I told you. So there is a lot of type of sensors. I think around 40 to 50 amount of sensors are available in a car nowadays. And these sensors are detecting all the problems inside, and these sensors are detecting all the problems inside, and that problems it find out, and it will, yeah, it will give an information to us through the medium like the monitor or the something like not starting or something like yeah, it gives information. Suppose if we don't know the information, if we didn't give the information, then we will give this our car into a repair shop, and the repair shop first they analyzing by using there is an analyzer. That analyzer detect what are the problems inside the car actually. Okay, see, the second is the electronic control unit. So this is one of the very important part in our car. So this electronic control unit which collect the signals from the various sensors. See, this ECU or the electronic control unit, which module which contain there is a lot of microprocessors and memory units and also some digital converters. Okay, so these converters or these microprocessors process all the information obtained from the sensors and then giving as an output to us actually. So it allows the ECU to tailor to the some specific engines or some engine requirements. Okay, so the operating software of the ECU can be adapted for a worldwide variety of the engines. So ECU is usually located in the cab or some certain cases like some suitable position in the engine actually. Okay, engine belt തന്നെയായിരിക്കും ഈ ECU situate ചെയ്തിട്ടുണ്ടാവുക. Okay, now we can see that yeah. Here, another thing is the actuators or the solenoids. So these are the part actually which is when the electronic control unit creates up signals, and these mechanical, partially mechanical type of devices are these actuators and solenoids. So these are usually located on the fuel pump. So in the case of fuel case, or in the cases of our engine fuel case or the fuel pump, okay, so which is near to the fuel pump and transfer the electrical signals into mechanical action. So see here you can see that this electronic device, okay, electronic magnetic actuators actually giving the mechanical work to the system actually. Okay, see we get the information through the sensors and we will give that information to our EDC, and that EDC is actually using their control module, using a control module to information, and the EDC, that control module decides how much amount of the fuel is required to give actually. Okay, how much fuel is giving to this cylinder and how much fuel is, should be mixed, and what is the speed, engine speed. Suppose you imagine that when you are going heavy fast or fast driving, so it requires more fuel combination to the cylinder actually, isn't it? So what you do is you give that information, that is we need the more acceleration or we need more speed, so we will press acceleration more, and what happens, there is a sensor, that sensor gives information to the processor, and that processor gives an information to the what, actually the actuator or the solenoid, and the solenoid what releases more fuel to the engine actually. Okay, see, now here you can see that there is a lot of parts like injectors, boost pressure actuators, intake dust switch off, throttle valve actuators, and AC compressor, auxiliary heating, and radiator fan. And all these things are connected with this EDC pump actuator. Okay, right. Now we can see the working principle of EDC actually. Okay, so the injection of the fuel or the quantity of the injected fuel has a device influence on the some engine starting, idling, power, and emissions. So these are the conditions. Mainly, this EDU or the ECU is programmed. Okay, so the engine ECU is programmed with a certain relevant data where the fuel rack pinion has an equivalent signal to the amount of the fuel being injected. See, suppose there is a mainly four conditions. First one is the initial starting condition. Second one is the ideal condition. That means when we are going to somewhere and we will block or some traffic, there will be some we are stopping. Okay, our vehicle, but it is we will not turn off our vehicle, but we are still there. That is an ideal position. And the third one is the power. That means we have to go high speed actually, and the emissions. So for all these conditions, there will be the ECU is marked for the certain programming actually. Okay, suppose when we press our pedal in the full speed, this must be the speed, and this must be the fuel. This amount of the fuel should be given to the cylinder like that, etc. So the driver requires the torque or the engine speed requirement by an accelerator pedal or some potentiometer, thereby sending a signal to the ECU. And what happens? This mapping the data collected the various sensors and calculate the real time, okay, and how much quantity is fuel should be injected, and this alternate the fuel rack and require the position. So what happens? The driver can also input the additional commands such as the speed, idle speed increase, or to compensate. So the PTO or the operation which can either be variable or having a preset speed which can be recalled. Okay, so some road speed functions can be used to evaluate some engine speed actually, or the vehicle speed possibility, activate the speed limits. Okay, so you can see that there is a governor or some cruise control. I think you heard about the governor actually. So that means our heavy vehicles or the some lorries or trucks, it should be go not more than some 70 or 80, 70 kilometers per hour actually. I think that is a different. Okay, some states it is a different actually, but minimum there will be 70 kilometer per hour is the maximum speed allowed for in Indian roads actually for the heavy vehicles. So for that actually there is some governors will be there. So that governor is controlling here actually. So in this EDU. So you know that the cruise control, that means a specific speed or a set speed. Some more some cruise control is some luxury cars having some cruise control. That control is that if you press the switch, what happens? The car going to the same speed, exactly the same speed what currently is in there actually. So that means if you are going to a 40 kilometer, you don't need to press the accelerator. It will go for 40 kilometers per hour in a same speed in the long same road actually. Okay, so that is a cruise control. Okay, so you can set a speed in the cruise control. When you press a brake, what happens? The switch is turn off, and what happens? It mingling with your speed actually, your controls actually. Okay. Now there are some further functions. It can also include to exhaust the brake operation, which is inactivated. Okay, so that I already told you. So the engine ECU can also interface with the various other vehicle systems like traction control or some monitoring with the self monitoring duties or some diagnostic functions. Okay, so ECU can also perform these things like the traction control and also self monitoring of the duties and some self diagnostic functions also. Okay, so you can see that you heard about it. I mean, some diagnostics methods they are using in the workshop or the service centers. Okay, like to ensure that so these is diagnostics method we are using to safe operation and suppose there is some failure to understand about what are the failures are occurring there or not. Okay, right. Now, what we are going to study is about the fuel injection system. Here you can see that in this figure, I think the figure is not that much clear, but okay. Anyway, you can see that here. So this is our engine. Okay. So here you can see that there is a fuel tank, and from the fuel tank, the fuel is starting by using a pump actually. So here you can see that there is a pump. So the pump is picking this fuel from the here tank, and it is through here. It is you can see that it is allowed to flow through our channel, and here where it reached the fuel tank filter actually. So first it reached to a fuel filter, and from the fuel filter there is a filter plug will be there and breather will be there, and from the fuel filter you can see that it flow where actually. So it flow here, you can see that here is this way it flow and reaches here actually. So you can see that the overflow of this valve will be available, and this overflow valve is directly connected with our tank, the fuel tank, and it will go here actually. Okay, right. Then what we do is we will supply this fuel into here actually, and then the tank that means our engine, and then from the each valve it is connected to the each cylinders, and it provide, and what happens? So through the injector, so there will be some injector lines will be there. That line is connected to each actually. So this injector lines is connected to each valve actually, and that means each cylinder actually, and if the fuel is injecting, and if there is a balance that is connected to here in the tank and it goes out. Okay, so this is a supply pump and this is a hand primer actually. So see, suppose you can see that there is some old engines, there is a hand primer will be there, so it is also provided in here actually. So now you can see the centrifugal governor will be available to control the fuel amount, how much fuel is needed to the engine. So this is a centrifugal governor is connected. Okay, so this is the basic diagram for this engine, the fuel flowing into the engine actually. Okay, right. So now you can see next to the fuel path actually fuel injector. You can see here the fuel injector. This is one of the major part which allowed to supply the fuel into our each cylinder actually. So what is a fuel injector actually? Okay. So fuel injection system is an admitting fuel to internal combustion engine and becomes the primary fuel delivery systems. So you can see that this is in automobile. You can see that it is replaced by the carburetor by using the 1980s and 1990s. So 1980s to 1990s up to here we are using the carburetor system for delivering the fuel actually. But nowadays we are using a fuel injector system. See, so this is a cross section of the fuel injection injectors. You can see that there is a spring inside and there is a reed inside, there is an armature coil and there is a flow analysis actually. See how much fuel is required for to transfer this through this channel. We decided by using the ECS module. See, ECS modules control all over this how much fuel is required actually. So we control here in the system. So we will go for elaborately in later. But here you can see. So there is a primary difference between the carburetor and the fuel injection is that the fuel injection optimizes the fuel by forcing pumping it through a small nozzle under high pressure. While the carburetor case, here you can see that there is a suction is created to intake air accelerated through the venturi tube and draw the fuel into the air stream. So in the last class, I already told about the venturi tube and this carburetor in very detailed. Okay, so through there is a venturi tube will be available, and inside the venturi tube there will be air is released. So that air is atomizes that fuel, and the fuel is reached into the cylinder. In that case, in the carburetor system, we studied in that case. But here, what happens is that here we are giving some fuel, small amount of fuel, and it atomises by using a pumping through the fuel nozzle with the high pressure actually. Okay, so very small nozzle will be available. So through that nozzle, the fuel is having a very atomizes or get atomizes. If you have a doubt, you can see that in your kitchen, you can see that there is a pressure cooker will be available. Okay, you can see that in your kitchen there is a pressure cooker. During the lunch time, you just go there and you see that you are inside the kitchen. Your mom prepares some like a rice, and the pressure will be coming out. You can see that over the pressure, you can see that there will be the air that the water inside this becomes a steam and it atomizes. Okay, atomizes that water outside. When you remove that lock from the top of the cooker, and you can see that the through air water atomizes. Okay, the inside the water is atomizes and go out. Okay, high pressure air. You can see. So, but do it safely. Don't do it. Okay, right now you can see that this is the principle of the fuel injector actually. Okay, so now in the modern fuel systems which is designed to specifically for the type of the fuel is used, suppose. So you can see that there is a multiple grades of the fuels are available nowadays. You can see that there are different types of fuels are available, and we are using the most of fuel injection systems are the gasoline and diesel applications. Okay, now next one is a battery ignition system. So battery ignition systems are having the following elements. First one is there is a primary ignition circuit will be there, and there is a battery ignition switch and primary winding of the coil and a circuit breaker, and there is a capacitor and ignition circuit and an ignition coil, secondary winding coil, and also there will be a rotor and spark plugs and wires. Okay, so these are the ignition systems, okay, for battery ignition system. Now you can see that ignition system board actually inside the ignition system there is a magneto system of the ignition switch will be there, and that contractor that distributes the contractor breaker coil and the magneto condenser power generation spark generate the magneto unit or the rotor arm actually. So you can see that there is a spark plug, and that spark plug is there is a spark plug ignition system. There is a magneto system is used for to ignition switch. Okay, so in the ignition system, a dynamo or this alternator distributor or something like a circuit breaker coil is used for this ignition system. Okay, so ignition system here the ignition switch coils packs an ignition system. See, so both CI engine or the SI engine having the ignition systems, but here in the CI system, ignition system is a little bit different actually. Okay, so comparatively, there is a spark plug in directly in the cases of our SI engine. But in here there is an ignition system, that is a small ignition system is available, but it's just not like a smart plug, but it's a small ignition system we are providing actually. Okay, so in the smart ignition engine, there will be some gasoline cylinder with having a 2 or 4 stroke cycle principle, utilizing the carburetor as the fuel injection system, and also some air mixture is ignited by an electric spark. But in the term spark ignition, it means a brief electric arc is produced. Okay, but in the case of here, the most cases the power sources of this vehicle battery, which uses most because for making the spark ignite. But here in the case of there is no need of the spark ignition. Okay, right. So we'll go for the circuit diagram of the ignition circuit here. Okay. So in case this is a spark ignition system actually. Okay. Yeah, this is not in the case of CI engine case. Here you can see there is an ignition circuit. Okay. So you can see that there is a circuit breaker and there is a coil, ignition coil. There is a starter motor and battery. See, you have a battery. First, you give some power to the starter motor. So initially it rotates. What rotates? The starter motor rotates the engine wheel. The engine is rotating. And what happens? The engine is rotating. So it means that the cylinder inside is moving up and downwards. And at the same time, the ignition coil gives some energy to our distributor cap, and this energy to the spark plug, and spark plug gives the firing order to and fires actually. Okay, so this is the system for the SI engine actually. Okay, so but here we are giving this common rail fuel injection system. So most of the cases in the diesel engines, CRDI, or you can see that CRDA. So this is the main system we are using for ignition for the or the fuel supply system for the diesel engine cases. Okay, right. So here you can see that the common rail direct fuel injection system is one of the modern variant of the direct fuel injection system. Here you can see that this is also used for petrol and also with the diesel engines. And in the diesel engine, it features on a high pressure, that for example, 100 bar or 100 megapascal. Okay, so the fuel reel bearing individual solenoid valves. Okay, so that's supposed to lower the pressure fuel and pump to feed it. And what happens? Pump to feed that fuel injector. Okay, you can see that there is no carburetor here. So here you are going to give some this high pressure amount of fuel is to injectors, and it injects to the cylinder directly. Okay. So in the cylinder, when it inject, what happens? Suddenly high pressure air is also there and it bombards. So how it is, we will go through that. Okay. So yeah, okay. So we will study the CRDI in the next class, I think, and I will post our Google form into our yeah our group actually. Okay. Anyway, thank you for coming here. Okay.